Okay, let's talk about the Agar problem. So let's just hang out in paint over here, and then we'll talk about the rules of the world that we're supposed to implement. Let's set up a situation where a big Agar has to eat a small Agar. So I'm going to draw our hash set here, which has a couple bins. I guess it can have 0, 1, 2, 3, 4. So that's 5 bins. All right. Let's just call this number m. So you got m equals 5. And then let's put a small little Agar right in here. And then we have a bigger Agar that's like over here. And he's going to come in, and they also happen to both hash to bin number 1. And the big Agar happens to be of size, whatever this guy is. Let's say this guy's size is, I don't know, 4. Then this guy's size is s equal to 8. And then it hashes to the same bin, luckily. Then this guy is very happy because he gets to eat a small Agar. So he says, yum. This is a condition in which it eats. Okay, now if I change this Agar size to, I don't know, something else like 2, it is smaller than 8, but that's not what the problem describes. So you only eat if the small Agar is half the size of the big Agar. Okay, now let me draw another situation just to also build some further intuition of the rules. Again, we have a 0, 1, 2, 3, 4, and let's this time instead stick the big Agar in here. He's waiting, okay? He's waiting to eat something. And then a small one comes in. Do we eat in this case? We don't. We don't. We specify in the problem that you only eat upon insertion. So this one can potentially eat something, but he's not going to get eaten. Okay. If there's a small one in here, there happened to be another small one. This one's even smaller than this one. This one's like a little bit bigger than that. And this one is half the size of this one, then yes, it would eat. And this guy doesn't do anything. Don't worry about the big guys inside the set. They're all inert, except whenever you insert. Okay. So we can break down the conditions for eating into just 2 cases that need to be satisfied. And let's actually write them out, because we're going to write the code for that soon. So 2 conditions, all right? We got 1 and then 2. First, I guess the small Agar, this one, and then this one, they have to be inside the set in the first place, okay? If the set was kind of empty, then you know that there's going to be no eating, right? This guy's going to come in, and he's got nothing to eat. There's nothing in any bin. So the small Agar has to be inside the set in the first place. That's the first condition, okay? And you can imagine that, let's think ahead. You can imagine it's going to be something like set.contains or something like that. We'll work out the details later. And the second condition is that both Agars have to hash to the same bin. Okay, so this small one, and actually this is a bad example. This one was the bad example where it didn't actually eat. But in this example, we just have this small one that's been circled a couple times, and the big one comes in. It's of size 4. Then when this comes in, they both need to hash to bin number 1. Okay, you can't have it so that the small one's in 3 or the small one's in 4. That's not going to eat. They have to hash to the same bin. So both Agars have to hash to the same bin. Well, I guess let's think about it. We can imagine that there's going to be something to do with .hashcode, maybe, and then some other thing about maybe modding. But we'll talk about that in depth a little bit more later. So actually, let's go ahead and write out the code for that. So it's going to be returning a Boolean. This should eat something. And it takes in 3 arguments. What were the arguments? There's a Agar X, and then hash set of Agars of set, and then int m. That was the arguments, I believe. Okay, so we need both of these conditions, right? So if we could actually just, at the end, first we're going to calculate, I don't know, suppose we have Boolean B1, and then Boolean B2, and then we're going to, define these to be something. I got to do that part. Just these dots are just a reminder to do it in a little bit. We can just return B1 and B2. So if both conditions are satisfied, then we should eat. Otherwise, we shouldn't eat. So B1, this one says, what did I say here? The small Agar has to be inside the set in the first place, set.contains. Okay, so what we can do is we can do set.contains, and although we don't have the pointer to the exact Agar that we're supposed to work with, the way hash sets work and the way that our equals is defined for our Agar, if we can just make an Agar of the same size, it's exactly the same as the Agar inside the set. So we can just make a little dummy Agar of half the size, and this will work. So for B2, what did I say over here? Both Agars have to hash to the same bin. Okay, so what we can do is we can, again, I'm going to break this up without filling it in yet. If this one, if this one is equal to, this is going to be the first bin, and this is going to be the second bin. The first bin meaning the bin that the big one goes to and the bin that the small one goes to. If they're equal, then we're good. So what we can do is we can use the public method hash code and then mod it by m, and then that's the bin number that it must go in. So we say x.hashcode mod m, and then do the same thing, but instead of x, we do it for a small agar. And actually, we need to go ahead and make that. So let's just say agar small agar is equal to new agar of size x.size divided by 2. So this will work. Actually, we could potentially clean this up so that this thing actually just uses small agar. This will work too. This is a cleaner way to do it. So that's it for should eat something. Now we need to write the next part B, which is, I think it was insert agar, and then the same arguments. So let me just go ahead and copy these. And so inside here, we have two conditions. Either the agar that we need to insert, x, either it needs to eat or it shouldn't eat. So let's go ahead and set up that if statement. Again, I'm not really going to fill out the stuff yet. This is let me write a comment, should eat, and then this one is shouldn't eat. And how do we split into these two cases? Well, we can just go ahead and use the should eat something that we just defined. That's very handy. So we'll do should eat something, and then what are the arguments? The arguments are going to be the same as whatever you pass in, right? So both these arguments are defined. This one is defined the same as that one. So what we can do is just, again, copy our stuff and paste it in there, and then actually we have to take off the definition. So you're passing in the same stuff. And then from here, we narrowed it to the two cases where we should eat and shouldn't eat. Let's handle the shouldn't eat case because this one's easier. So if you shouldn't eat, then you can just insert into the set as normal. So we can just call set.add x. That's okay. And some people said set.insert, although that's not a real method of set. We just took it because we know what you meant was add. So that's okay. So that's it for if you shouldn't eat. Well, if you should eat, then you got something to do, right? Because then you have to, let's go back to our picture over here. If you have to eat, let me draw another situation because those other two situations got messied up. So if there's a small one and there's a big one, it's going to come in and eat it. Then you got multiple things that have to happen. This one has to disappear, has to get eaten. Basically, that just means it gets removed from the set. And this big one has to grow up a little bit, right? So he's going to turn into some kind of bigger one. And he's happier because he just ate. So then what we can do is we can break that into two parts, right? First, let's remove the small one. So we can say, again, we do the same idea with this dummy business where you create a small agar. Agar small agar is equal to new agar of x.size divided by 2. And then we say set.remove of small agar. And this will work, right? And so notice that this small agar is not exactly the same agar that's inside the set. But the way that hash sets work and the way that we successfully define our equals, then anything with the same size is the same agar, right? That's what we talked about before. So the set.remove small agar will effectively remove the small one. This will work. So then after that, what was our second thing? Second, we need to grow up. So we need to have the one that just ate grow up. So we can just say x.size plus equals to small agar.size. So that'll handle the growing. And then finally, the problem says we need to attempt to insert again. So then what we can do here is set.addx, right? Well, actually, we can't just do this right here because this, what if you need to eat again? What if you have a situation where a big agar comes in, eats a small one, and after it eats it and grows by a little bit, it needs to eat yet another one? Then this doesn't handle it. So we need to make a recursive call to insert agar here. So we can say x, set, and m again. Because this is now our grown-up agar, so it's okay. So there were some other solutions, and let me just take a moment to talk about some other solutions that also work but aren't potentially as fast. So this should eat something. Let's create a duplicate version here. So I'm going to write a slower version of should eat something. We'll call it should eat something, I don't know, call it should eat something slow. So some other approaches were to iterate through the entire set and then look for an agar that satisfies the conditions and then remove that there. That one isn't as fast because, again, you have to look through the entire set. You're searching through the set until you find that small one. And then sometimes you break out early. Sometimes you have to look in the worst case, at every single agar, that's linear time. That's guaranteed, you're going to look at every single element. Whereas over here in the should eat something not slow, so should eat something fast, this one, you can just create a small agar that's constant time and then do set.contains, that's also constant time. Assuming good hashing, then this entire method is going to be constant time, whereas this one is going to be linear time even if you have great hashing. So that's why this one didn't receive full points. I'm actually not going to write out the solution. I went back on my word. For also, one more thing to talk about. Some people interpreted should eat something as it would actually remove it. So down over here, it would say something like set.remove and then actually execute the removal of the small agar. But although this wasn't intended, if this worked with your insert agar, then you deserved points for the insert agar point. I mean, you didn't get dock points for doing that inside should eat something. And if it worked with your insert agar, then we just said that's fine, as long as your integrated code works. So that's the review of agar, and hopefully this was helpful. So have a good day.